bunch of different reflections. So a reflection is a rigid motion in which each point in the pre-image is the same distance from the line of reflection as the corresponding point is in the image. Now that sounds really difficult, but reflections are pretty easy. All we're going to do is take a point and we're going to reflect it about a line. So the line can be the x-axis or the y-axis, or it could be like a vertical line like x equals 5, or it could even be a line like y equals x. And so when I said the word rigid motion, it just means that the object is the exact same object when I reflect it. So if it's a square and I reflect it over a line, it's still going to be a square. If I take a triangle and reflect it, it's still going to be a triangle. So the object, the original object we call the pre-image, and then the reflected object is called the image. They are congruent, meaning they are the exact same shape, same side lengths, same angles, same thing. Okay, so let's just do a point here. So I'm in GeoGebra, and if you wanted to do this, you could just Google GeoGebra geometry, and I just put a grid line in, I drew some lines. So I'm going to go down here to reflection. So I select reflect about a line, and it tells me what to do. It says select object, and then reflect the line. So I'm going to take E, and I'm going to reflect it about the y-axis. And you can see this is the pre-image, and then this is the image. They call this E, and then they call this E prime. That little markup there is prime. And you can see that E was 2 units away from the y-axis, and so now it's 2 units away that way. Right? I could take E, and I could reflect it about the x-axis. And it's going to go, it's 3 away, and it's 3 away. It went all the way down here. That makes sense? And again, I'm going to go through a whole bunch of different shapes. So a reflection is rigid. Means the object is the exact same, and it keeps the distance the same from the object and the line of reflection. So if it was 3 units away, it'll be 3 units away. It was only 2 units away, it'll be 2 units away. Okay, so let's click on this next tab. Oh, sorry, I had to go this way. Okay, so now I have this polygon, which is kind of like an L shape, and I'm going to reflect it a bunch of different things. And again, I'm going to select the polygon, and then I'm going to do the y-axis here. Okay, and you can look, each point is reflected, which means the whole shape is reflected. But to draw them, you really only have to reflect one point, and then the rest of it, I think, is kind of obvious of what it should look like. But here's E, the pre-image, and then here's E prime. You can see E and E prime are both 2 away from the axis. F is 5 away from the axis, and then it's 5 away again. But you also make sure that FE is 3 units long. Well, then E prime and F prime are 3 units long because it has to be the same shape. This was 1 unit, this was 1 unit. So reflecting the shape is the same thing as reflecting each one of those points, but usually if you just reflect 2 of the points and the rest of the shapes, you can draw. You know, this is a 1 by 1 and this is a 1 by 1. Again, the shape is the exact same shape, and they're around. So I can take that, I can reflect this shape on the x-axis, and it's going to look down like that. And again, look at G prime went to G double prime. So it's 3 units away, and it's 3 units away. F was 5 units above the line of reflection, and now F prime was, and now F double prime is 5 units below. I can do this as many times as I want. I can even reflect it one more time, and we can notice something. Let's take that object and reflect it there. Now I have triple primes. And you can notice that I have to reflect, 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 and if I reflected one more time, I would actually go right back on to the original image. So I'd have the pre-image, the image, the second image, and then the third image, and I would actually go back if I reflected again. So if we do all those reflections, it's the same thing as actually not doing anything, which makes sense. We're back to that same shape. Okay, so we did those. We did a point. Okay, let's do a triangle here. I think that was maybe a little more interesting. That's not what I wanted. I wanted that guy. More. Go down here to, let's make that a little smaller. Okay, so we want to reflect about a line. So let's take this object and reflect about that axis. And you see, same thing. H was 2 away. Now H prime is there. G, G prime, I prime. And again, you can flip as many of these as you want. Reflect about this line, the axis, and you can see it flip down. Again, you have to be able to draw all these and look at these transformations. Okay. All right, how about, oh, no, let's do, oh yeah, let's do this one. So this one is going to be the most challenging one, okay? So instead of reflecting, oh, you know what I wanted to do? I actually wanted to take this, let's make a line. I knew I wanted to do this. Let's make a line. So I got to make a line. Okay, there's a new line. And I don't want to do it over an axis anymore. Again, because this axis is kind of easy. It's just going to go, in this case, I'll show these again. So if I were to take, where am I at? All the way down. Reflect about a line. So there's a polygon, and there's my line. And if you see, H, it's at the exact same height. So all I did to reflect over here is that the X value went from like -2 to 2. The Y value stayed the same. -3 to then 3. -5 to 5. So reflecting over that's pretty easy. But what if I wanted to reflect over this line? So if I want to reflect over some random line, so this is 1, 2, 3, 4, 5, 6. This is the line right here, y equals 6. I can reflect over it if I wanted to. I can reflect over any line I want. It's still just counting, so I'm taking that polygon and reflecting over that line. And let me move everything a little bit. That was moving the line. That's not what I wanted to do. I just wanted to move the whole thing. There we go. You can see then all I'm doing is G is, 3 units down from that line. So then G prime is 3 units up from that line. It still maintains the distance you are from the line of reflection, no matter where that line of reflection is. And actually the cool thing is I can even take this line of reflection and I can move it. So if I move the line of reflection, I'm even moving the image associated with it. Okay, now that is pretty cool, right? I don't know if I can actually move that line. Oh, I can move that line too. See? If I move the line, then I'm changing the distance the reflection is from the pre-image. So far, so good. Okay, so we did just a point, kind of an L-shaped thing. Then we did a triangle. Now let's do this guy. Okay, so this guy is going to be more difficult because it's not a horizontal or vertical line. Now it's the line y equals x. So this line, y equals x, has a slope of 1, right? Over 1, up 1, over 1, up 1, and it goes to the origin. So here, what you want to do is that it's going to go perpendicular. So what we're going to realize is that when you reflect over a line, that point is going to go perpendicular over this thing. So this G is going to go right down to here, right across these diagonals and end up right there. See how it's kind of like 1 over and 2 up? Well, it's going to be 2 down, or 2 over and 1 down then. It's going to be the exact opposite. So let's see how that will work. Make that a little smaller. And again, you have access to this. This is just me going on to Google. So reflect this object about this line. Okay, so check that out, how that works. So it doesn't go horizontal over it. It doesn't go vertical over it. It goes perpendicular over it. And what you can see is that H, if you looked at it, is -1, 5. Then H prime is going to be 5, -1. They both switched. They switched x and y. Whatever x comma y this is actually y comma x. I'm not sure that's a necessary thing to know, but you have to be able to look perpendicular. So if you follow this perpendicular across this, you're going to end up, boom, right at H prime. If we actually draw those lines, so draw these line segments, I can show you that all of them go perpendicular, meaning they all have the opposite reciprocal slope of this. Well, this had a slope of 1, so all of these have a slope of -1. And again, you can draw, as many as you want. It might actually get a little more confusing if you keep drawing them, but you just take it and take it perpendicular across. So actually, it wouldn't matter what this line was. We'll probably just do y equals x, but it could be y equals whatever we want it to be. You just have to use an opposite reciprocal slope to make sure you're perpendicular across that line. Now remember, when we did horizontal lines, of course, this, see that line? Oh, actually, I don't want that line. I want the line segment. Line segment, if you look at that, boom to boom, all of these are perpendicular to the line of reflection. It's just boring because if the line of reflection is horizontal, well then of course that's going to be a vertical thing. In this case, this is a y equals x, and so this ends up being -1 slopes down. Again, it's the same shape because it's a rigid reflection, and algebraically what you're doing is you're taking any of these coordinates, x comma y, and then they become y comma x. Okay, and then I think this last one, I'm actually not positive that GeoGebra will let me do this, is that I want to have a shape that's actually straddling the line of reflection. I'm not positive it's going to do this. I didn't try it out first. But you should be able to take this and kind of rotate it about that line. So to rotate about a line. So take that shape and, oh yeah, it does it. Okay, so this is an example of where I'm going to flip it around. And it's kind of hard to draw that one, but stick to the principles. E gets reflected over there. G gets reflected that way. And F gets reflected that way. And so, again, look at it again. It's that shape. And then it's going to twist around that thing. So if you have a shape that's around it, we can probably just do another one quick, right? Let's make a polygon. So let's make this. Okay, so there's my polygon, and if I take that one and I rotate it about this line, the 1 thing is going to flip down here, and then the 3 thing will flip up. So take that shape around that line and kind of see what I have now. Okay, so H prime went down, K went down, and then the other one's flipped up. Okay, so looking at lines of reflection, you can reflect points, you can reflect shapes across the axis, you can reflect shapes across random lines, triangles or still triangles. You can reflect any shape you want or any point you want across the line, y equals x, or y equals -x would be the same thing. And then you can even reflect a shape in a line that's going in between the shape. So the line of reflection is here, and we can just flip that bad boy around and get that. Okay, hopefully this gives you a pretty good visual of what, you know, reflections do, and you should be able to take, like I said, any of those shapes and any of those lines and reflect them.